The simplest continuous random variables have a probability density function that's just a horizontal line. They're called uniform random variables. So here's the density function. It goes from a to b and then it's 0 everywhere else. And it's a height of 1 over b minus a, so that the base times height, the area here is b minus a times 1 over b minus a. So that's an area of 1 in there. So we'll call x uniform and write x is uniform on the interval from a to b if predicting x is like choosing a point in this region and recording the x coordinate. So I claim that the probability that x is between, let's say, little x1 and little x2 is x2 minus x1 over b minus a. So we can pretty much draw the proof. If this is x1 and this is x2, we're looking for the area of this region over the area of the whole region, which is 1. So just the area of this region. And the area is base times height, which is x2 minus x1 times height, 1 over b minus a. So that's all there is. I guess we could, I said this with area, but we could really do this with just a line segment. So we have the real number line with a and b on it, and we're picking a point at random in this segment and then asking, is it between x1 and x2? So we could call that this length divided by the whole length. The whole length is 1, so it's really just the length of the segment from x1 to x2. Well, I guess to make this whole segment 1, we need to have a height of b minus a. So it's length of this segment, x2 minus x1, over length of the whole segment, b minus a. So let's compute the expected value of x squared, and the variance. Oh, let's do an example first. So let's say we'll pick a real number between 0 and 20. Let's say that real number is x. And then ask, what is the probability that x is between, say, 13 and 15? So it's just 15 minus 13 over 20 minus 0. So the length of this segment divided by the length of the whole segment. So it's 2 over 20, which is 1/10. So these continuous random variables are so easy that we don't even really need to integrate, because we can just take length over length. All right, so now let's do expected value of x. So these are always for x uniform on the interval from a to b. So the expected value of x is b plus a over 2. So to prove this, we will integrate. Expected value of x is the integral from a to b of x times the probability density function 1 over b minus a. Which is 1 over b minus a times, if we integrate x, we get x squared over 2, and then we evaluate that from a to b. So that's b squared minus a squared over 2b minus a. B squared minus a squared is b minus a times b plus a. That's all over 2b minus a. B minus a is canceled, and that leaves us with b plus a over 2, like we claimed. Now let's look at the expected value of x squared. I claim that this is b squared plus ab plus a squared over 3. And the proof is just about the same. Expected value of x squared is the integral of x squared times 1 over b minus a dx, which is 1 over b minus a, x cubed over 3 evaluated from a to b. So b cubed minus a cubed over 3 b minus a. Now b cubed minus a cubed factors as b minus a times b squared plus ab plus a squared. So that over 3b minus a. The b minus a is cancel, and we've got the fraction that we claimed. I claim that the variance of x is b minus a, the quantity squared over 12. To see this, well, the variance is expected value of x squared minus expected value of x, the quantity squared. We just computed both of those things. So it is b squared plus ab plus a squared over 3 minus b plus a, the quantity squared over 2. Now if we combine these two fractions, I guess we'll multiply the left one by 2 over 2 and the right one by 3 over 3. So 2b squared plus 2ab plus 2a squared minus 3b squared plus 2ab plus a squared all over 6. So we have two b squared minus 3b squared is minus b squared. 2a squared minus 3a squared is minus a squared. 2ab minus 6ab is minus 4ab all over 6. Oh darn it, I forgot to square the 2 here. This is b minus a over 2, the whole thing squared, which means the denominator needs to get squared too. And I guess there's so much glare here that it doesn't hurt if I really erase that anyway. So you can see this is b plus a, the quantity squared, over 2 squared. And that equals, so multiply this by 4 over 4. 4b squared plus 4ab plus 4a squared minus 3b squared plus 2ab plus a squared. All of this over 4 times 3, 12, which is, let's see, 4b squared minus 3b squared is b squared. 4a squared minus 3a squared is a squared. 4ab minus 6ab is minus 2ab, all over 12, and that is b minus a, the quantity squared, over 12.